Welcome students. In today's session, we are going to see about the database management system and how we are going to model the database and what are the views we have in database management system. All these things we are going to see in this session. And also along with these things, you will be seeing about the different kind of the database server or the servers what we have for developing a software. So we will be discussing about those servers also, and followed by that you will be discussing about how to design the access layer. So to build an access layer you have some rules, so you will be seeing about those rules in the following session. Let us get into the session. First we will see about database management system. A database management system is a single repository, that is, it is a single place where you will be storing your data. So that is why it is called as a single repository where the data is maintained. And then each and every database management system will have the definition of its data formats. So you have some information about the formats of the data what you have stored in your database management system. So these data formats are called as metadata. So every database management system will have the information about metadata. This metadata is nothing but it will give the information about the format of data what you have stored in your database management system. Next you will be seeing about database views. Database views in the sense, database management system will provide multiple kind of views. In the sense, it will provide some multiple virtual views to the user, so that some kind of user may able to see the logical layer, some kind of user may able to see the physical layer. So you have different types of views for different types of users. So in logical view, you will not be shown about the detailed structure of your database. You will be knowing about what is the data and what is the output, what is the input and what is the output. So you will not be knowing about what action is performed in the database to get that output. Whereas in physical view layer, you will be knowing about the changes what you are going to do or it is about to take place in the data. So why the input is taken and how it is processed and why you are getting the output like that format. So all the information about the formatting of data will be in the physical layer. So some users will be accessing the logical layer, some users will be using the physical layer. Now we are going to see about database models. Database models are logical constructs which will be giving about details about the data what you are going to use, so the structure of the data and the relationship what you have in those data. So the database model gives the details about the data and its relationship. You have different types of models. First model is hierarchical. Hierarchical in the sense you will be having an order by order layer there, and then you will be having a network model, and then you will be having an relational model. So these are some models what you follow in a database management system. Hierarchical database management system in the sense, hierarchical model in the sense, you will be having a data that will be called as a single root. So you will be having a single root, and under this single root you will be having the data in a tree format. So if you are following a tree format, then you will be calling that model as a hierarchical model. Here you can have a relationship called parent and child relationship. So the parent class properties can be used by the child classes. So if you are having a database model of the structure of a tree where you can have a parent-child relationship, then that model is called as a hierarchical model. Network model in the sense, it is similar to hierarchical model. Here you will be having more than one parent. So if you are having more than one parent or more than one root for a directory or a database, then that model is called as a network model. You have relational model. Next model is relational model. Relational model in the sense, here you will be maintaining the data in a table format. So the columns of each table is called as attributes, and this attributes defines the value of each domain values for the entries. So here the column represents the attributes. The attributes will be represented in the column, whereas the data of each tuple will be recorded in the row. Each row records a simple tuple, a single tuple, whereas each column represents an attribute for that tuple. Then in a table you will be having a primary key as well as a foreign key. Primary key in this sense, it is a combination of one or more attributes, but it will be unambiguously locating the each row in a table. So it is used to identify unique row in a table. Next is foreign key. Foreign key is again a primary key of another table that is embedded in another table to link these tables. So you will be having two tables. Primary key of this table will be embedded in the another table here in the second table, so that these two tables will get linked. So if this key which is used as a primary key in table 1 is used as an key which is used to link for the table 2, then that key is called as a foreign key in table 2. We are going to see about database interface. So interface for a database must include data definition language, a query, and a data manipulation language. So a database interface should have all these three things in it. And then you will be seeing about DDL, that is data definition language. Data definition language in the sense, so this is a language or it's a structure which is used to describe the structure and the relationship between object. So if you are having two or more objects, so this DDL language is used to represent the structure of the object as well as the relationship between those objects. DDL will be defining the data schema. So you will be calling it as database schema. The structure you will be calling it as database schema. Whereas you have data manipulation language, that is DML. DML is the language which is allowing the user to manipulate, or you have DML language, that is data manipulation language. This language allows the users to access the database and to manipulate it. You can do some changes in the data. So a query which is used to do the DML language should have all these four features. So these four features are: the query should give the information about domain of the discourse, in the sense on what basis you are asking the query. The domain of the query should be known by seeing the query. The next thing is element of greater interest, in the sense by using the query which output you are going to get, which element you are going to get. So that element should be clearly seen in that query. Next is what is the constraint or the condition you are going to use in the query to get the result. So that condition has to be clearly explained in the query. Next is you can have some ordering concept or sorting concept, grouping of element concept in your DML queries. So all these four things has to be explained detailed in your DML query. And a DML can be, a DML data manipulation language query can be procedural or a non-procedural. Procedural DML, in the sense you will be knowing about, the user will be able to specify data as well as how we will be getting the data. So these two information will be given by the user. So if the two information is given by the user in a query, then that query is called as a procedural DML query. If the user is giving only the data and if he is not giving how the data has to be retrieved, then if the user is giving only one information to get the result from the database, then that DML language is a non-procedural DML language. If you are given two information by the user, then that query is a procedural DML. If you are given only one information, then that query is a non-procedural DML query. Data manipulation language is independent of host language. The host language, in the sense programming languages like C, COBOL. So to implement the software, you will be using many host languages like C, COBOL. But to make this programming language to interact with the database, you have SQL queries, SQL software. So using this SQL queries, you will be embedding this SQL query in your host programming language. So these both will be running simultaneously, so that my software will be communicating with the database. It will be doing some changes in the database and it will be returning the value to the user. Shareability and the transaction. Next, the data and objects in the database will be accessed and shared by different applications. So when you will be having a concurrent access over the data and object by different application, this concurrent access may lead to conflict. So your database management system should have the ability to have maximum amount of sharing of these data without any integrity problem. So your DBMS should have the capacity to allow maximum number of users to share this data, but in that case also it should not provide any data integrity problem. So these are the features of sharing a data. So if you want to share a data in a database management system, so these should be the features, or these are the rules it has to be maintained. To make maximum amount of sharing without any data integrity problem, you can use concurrency policies. So concurrency policies, in the sense, by using these policies you should be able to maintain the integrity or the serial way of accessing the data. So in concurrency policy, a transaction should be done in a serial manner. So a user should be able to see the database as it is existing before or after a given transaction. So if you are going to write anything to the database, the user should be given the view of database before writing the data, or he should be given the view of database or after writing the data. So if you are doing an action, the user should be given either before the transaction or after the transaction view. So that has to be the policy which has to be maintained in concurrency. The next is serialization. Serialization also comes under shareability. Serialization, in the sense, when you have two or more transactions, everything has to be done in a serialized manner. To make everything to be done in a serialized manner, you can lock all the objects or records until all the transaction gets commits. Listen, here all the transaction get commits, in the sense, if the transaction is not getting committed, you will be reversing back all the actions to the previous state before the transaction is getting started. So that is what this line means. Next is, this type of locking the object is called as conservative or pessimistic policy. This is another name for serialization. Here in this conservative or pessimistic policy, you will be given a read lock or a write lock. Here, read lock, in the sense, if you are having an object, if it is given a write lock previously, if it is given a write lock, already if a user is writing the data, for that data you can be given a read lock only if the entire transaction can be serialized, or else the data should not be given a read lock. Here again I explain, when a data is given, if that data is already given a write lock, you can have a read lock over the data only if its entire transaction can be serialized, or else you cannot give a read lock over it. This applies for vice versa, that is, you can have a data where you have applied a read lock over it. For that data, again you can apply a write lock only if the entire transaction can be serialized, or else you cannot apply a write lock. The reverse is also true. Next you will be seeing about different types of databases. One is distributed database. Distributed database, in the sense, you will be having different portions of data residing in different nodes or drivers of the network. So you will be having different portions of data, dividing the data into portions and storing each portion of data in different systems. So whenever you need a data, you have to interlink with all the databases so that you can get a full data. Whereas in client server computing, you will be having a client and the server. So here the client will be sending only request. So the request will be taken by the server, and in the server you will be having the database. So the query given by the client will be manipulated by the server, and the result will be returned back to the client. So here in client server computing, client will be giving the queries and server will be manipulating the query with the help of database. And in client server computing, your server can be of any of the type, that is, your server can be a file server. File server, in the sense, it is the simplest form of server. With the file server, the client passes the request for files or file records over a network to the file server. Whereas in the database server, the database server is the server where you will be having the database alone. So this server is used for accessing the database alone. In the transaction server, the clients invoke the remote procedural call that resides on the server, and the database SQL engine also is invoked by the client. Whereas the server has the procedural statement and it executes those commands and returns the value back to the client. So you can have these three kind of server in a client server computing. And also for a client server computing, you can have entire architecture. If you are having a 2-tier architecture, a single server and a single client will be there. If you are having a 3-tier architecture, you will be having a client. This client will be sending its request to the local server, and that local server will be sending its request to the global server. The result will be returned back to in the reverse manner to the client. So you can have 2-tier, 3-tier. If you want to have 4-tier architecture, you can also have. So likewise, a client server computing model can be formed in an entire architecture. Next, we will be seeing about distributed processing. So this distributed processing and cooperative processing, all these processing is supported for distributed database model. If you are having a distributed database, that is if your database is residing on different types of systems or different system, then that type of database is called as distributed database. So to have an distributed processing, you need a distributed database. So in distributed processing, the distribution of application over different multiple processing platform, here you will be having applications. So these applications are distributed over different types of processing platforms, in the sense you will be having different OS models, different processing environments will be there. And here in distributed processing, if you are having a transaction, to complete a transaction, the transaction will be taken over by 2 or more processor, and those 2 or more processor will be doing the same transaction and complete the transaction. To be simple, you will be having 2 or more processor to complete a transaction. First part will be completed by processor 1. The second part will be completed by processor 2 after processor 1 completes it. The third part will be completed by processor 3 after the second part of the processor is getting completed. So one by one, processor 1 will be completing, and then processor 2 will be completing, after that processor 3 will be completing, and the whole process will get completed. So if this type of working is taking place, then that is called as distributed processing. Cooperative processing, in the sense, here also to complete a single transaction you need different type of processor or distinct processor, but here processor 1 will be doing one part of the transaction, processor 2 will be doing some part of the transaction concurrently. So when part 1 is done by processor 1, at the same time part 2 is done by processor 2 concurrently. So if the work is done concurrently by different processor to complete a transaction, then that transaction or the processes is called as cooperative processing. You have COBRA in the sense Common Object Request Broker architecture. Here this architecture is used to integrate distributed heterogeneous business applications and data. So here this COBRA will be having a communication channel. Using this communication channel, applications will be able to access the objects and will be able to request the data and services. So through this communication channel only, the application will be able to request the data and services. Then this COBRA will be having another thing called Common Object Environment, COE. So this COE is used to maintain the life cycle for the object. So COBRA is very important architecture. This architecture is used to maintain distributed database. So this architecture provides a channel and a common environment where you will be able to integrate with the database, and also you will be able to maintain the life cycle of the object. And then instead of COBRA, you can also have Microsoft ActiveX or DCOM in the sense Distributed Common Object Environment model. So here either you can have COBRA or else you can have Microsoft's ActiveX or you can have DCOM. Object relationship mapping. So you have some tools called object relational system tools. So these tools are able to make a relationship between table structures in the relational database. In a relational database, you will be storing the data in a table format. So this object relational system tools will be able to identify and give you the relationship between these tables. Here you have another tool called table class mapping tools. This tool is used to map relational data with the objects. That is, you have different type of mappings, that is table class mapping, table multiple classes mapping, table inherited classes mapping, tables inherited classes mapping. Table class mapping, in the sense it is a simple mapping. Here 1-to-1 mapping will be done, that is 1-to-1 mapping of a table to a class. So one table will be mapped to one class. Here each row in the table will be representing an object instance, and each column in the table will be representing an object attribute. So that is what table class mapping is. Next is table multiple classes mapping. Here 2 or more distinct non-inherited classes will have the properties that are mapped to columns in a single table. So here you have 2 or more distinct classes will be connected to a single class. I mean 2 or more non-inherited tables will be connected to the classes which are not inherited. Table multiple classes mapping. Here a single table will be mapping to multiple classes, but those classes should not be inherited to each other. At runtime, the mapped table row is accessed as an instance of one of the classes based on the column value in the table. Next is table inherited classes mapping. Here a single table, one table will be mapped to many classes that have common superclass. So here the classes will be inherited to each other, whereas in the previous one you will be having multiple classes but those classes will not be inherited. Here you will be having inherited classes. The next is tables inherited classes. So here in this mapping allows the translation of is a relationship that exists among the tables in a relational schema. Here you will be having, in mapping the columns to properties, you will be having single approach is to translate the column value into corresponding class property. Multiple database system, it's a database system that resides unobstructedly on the top of existing relational and object database where the file resides and represents a single database solution of all its user. In the sense, multiple database in the sense, here you will be having heterogeneous information which will be residing on all the databases, which will be residing on different systems, but multiple database will give you that you are having all these data in a single system. It will give an illusion to you. So if you are giving an illusion, then that system is called as a multi-database system. Federated multi-database system in the sense, it provides uniform access. So it gives an common access to the data stored in multiple databases. So in a multiple database system, you will be having data stored in multiple places, multiple databases. But in federated multi-database system, all the data what you have stored in different systems will be having an uniform access. Open database connectivity. Open database connectivity, that is ODBC, it's an application which is used to make the vendor neutral mechanism for independently accessing the multiple database system. So you will be having your application, this application will be able to communicate with the database with the help of open database connectivity, that is ODBC connectivity. Next, you will be having, next is we are going to see about designing the access layer classes. So here the main idea is to create the access layer classes, but that is, the next is designing access layer classes. Here the main idea is to create some set of classes which know how to communicate with the places where the data actually resides. Here the access layer's task is to perform two things. One is it has to translate the request and then it has to translate the result. So this access layer classes has to be designed in such a way that these two tasks are performed by those classes in a correct manner. Thank you students. In today's session we have completed a lot of things. In today's session we have seen about database management system, and then we have seen about database models, and then we have seen about different database interfaces, that is DDL, a query and a DML language, and then we have seen about the shareability of transaction, what we are doing in a database management system, so that to make the shareability you have seen about the concurrency policies. Next we have seen about the network models, different types of models, that is distributed databases and client server architectures. So you have seen in client server architecture, the server can be of any type of servers like transaction server or database server. So you can have any type of server, and you have next thing called Cobra, and instead of Cobra you can also have Microsoft ActiveX or DCOE. So you have many things to have instead of Cobra. Next we have seen about the multiple database management system, and then federated database management system. Before that we have seen about this table mapping, table classes mapping tools which is used for table class mapping, and finally we have seen about ODBC connectivity, and then we have seen the purpose of designing the access layer. So how we have to create the access layer classes and for what purpose these access layer classes has to be designed. So we have seen the purpose of access layer classes. Thank you.